force you to ask questions, but if somebody wants to come back with a comment or a question, I'm happy to take a few of those in that sense. Yeah, you might have to go to the microphone, I'm afraid, or shout, okay?
I can shout, okay. I think there's a trend which a lot of us see in science textbooks, that they have been simplified almost to the point where the only thing they tell you is the answers to the questions which are going to appear on the exam. What's your feeling about that kind of move? Especially, I mean, I don't want to get it Cambridge per se, but they do print these textbooks specifically for the courses.
I think it's wrong, okay? I think you have to have varying levels of complexity. Okay? If you don't, okay, if you do that all the time, the students are going to have a big problem when they are confronted with more difficult textbooks when they go to university or when they start reading scientific papers. Okay? There is a body of people who are engaged in research looking at adapting primary literature so that students can see or begin to see the way in which scientists actually present that kind of information. If that's the only kind of text that students are reading, then that, I think, is problematic, and you need to look for supplementary text. I mean, obviously the text is useful because the thing that dominates an awful lot of your thinking, that dominates an awful lot of students' thinking, is what's going to be on the exam and how do I answer it. Okay, so it serves that kind of function, but it doesn't serve the function of educating people about science. Yeah, sorry, you have to shout. So
that's okay. What you said about language-based activities being very important along with reading for terms, and in biology, as you mentioned yourself, there's ever-increasing addition of terms and research and all those things. And all of them are being included in the syllabus and the curriculum. So do you think there can be something done about how to go about teaching so much at the level of grade 8 onwards, and which students are finding it difficult to retain all the new terms?
I've got the greatest sympathy for your question. Okay, and I think as all I can say is I think as a society we have to come to terms with the fact that you cannot educate people in science and expect them to absorb all that kind of information. Okay, as I said, the problem basically you've got is that everybody wants their bit of knowledge, okay, in the curriculum. Okay, you can't be educated in science if you don't know this, if you don't know that, if you don't know this. Okay? I haven't got a good answer to your question, other than I think the kind of position that I would take is to say you've got to, the scientific community, and by scientific community I mean not just the scientists, I mean society and their expectations of science, have got to come to terms with the fact that really what's needed is it's rather like literature. Okay, you don't expect everybody to know every individual canon or the whole canon of English literature. You introduce them to certain bits of it because these are examples of great writing. I think what you've actually got to do in the case of science is you've got to say, well, we can't do all the science. Okay? There is more, I mean, there's more knowledge. I'm just not sure what the doubling of knowledge of science is at the moment, okay? But you can't keep squeezing it in. Okay? It puts the teachers under immense pressure, it puts the kids under immense pressure. We've got to pick a few topics and do that. It hasn't, that kind of realization I think is sort of dawning, but it's not sufficiently dawned. I mean, if I look at the Californian state standards where I am now, they're just horrendous. Okay, it's just a list of facts. Okay, and that's how it gets taught, and the students don't come away with any sense of excitement. What questions being answered in that sense, and so I think one. As teachers, and in my case as a science educator doing research, it's something that I argue against and attempt to resist, and that's all we can do.
I just have a question about the writing. Your table, it said in year 10, only 8% of the writing that's done by students in class is essay writing. To what extent do you think that's because of the way the exam is structured? I mean, there must be some kind of washback effect from the exam. Given that exams are, I'm not a science teacher, but I think mostly short answer questions. And
Yeah, I think this is. I think you put your finger on a quite important point, actually. Again, another of the tensions that exists, I think, around science education is that most people want people to learn science because they think it develops what you might call critical thinking or scientific reasoning. But your ability to use critical thinking in the context of science or scientific reasoning, it cannot really be examined by a multiple choice or short answer question. Okay? It can only really be examined by asking for some kind of extended reasoning. Okay? But the problem with that is the exam boards hate that. Okay? I'll let them speak. Because basically it means somebody's got to sit down and mark it. The reliability goes down because what you think is good is not what I think is good. Okay? And then it becomes expensive. Okay? And so basically, if they can, it goes out or it gets cut in that kind of way. Now, again, in some sense, a similar kind of answer to the last question. There is a lot of people out there, I think, in industry, worried that the kind of science education we are offering is not developing those kinds of critical skills of thinking and reasoning. There's a very big project that I know Microsoft and Cisco are funding, looking at assessment systems that will assess scientific reasoning. It's a particular interest of my own. And I think that kind of tension, they're aware of that kind of tension, and how can you develop effective means of assessing that kind of skill? Because the real lever, as you know, and I'm sure many of on what teachers do and what you teach, is not what's on the curriculum, it's what's on the examinations. Okay, actually, we really do have to put a lot of effort into thinking about how do we get examinations which match the kinds of skills that we want to develop, and some of the kinds of things I've been talking about.
So, to what extent does university, or are the universities responsible for the kind of exams that are set? For instance, if first-year university students are not expected, perhaps I'm just speaking about my country, to write too many essays, perhaps it's not seen as an essential skill. Who really bears the responsibility? Is it a school into university or university back into school?
Well, I think the answer is there's a bit of both. Although in this case, I would lay a lot of the blame, okay, or a lot of the problem in the context of universities, because I think the quality of science teaching, in my opinion, where it is at its weakest, okay, is in universities. And there are a whole host of reasons for that. Principally, most of the people have been employed not because they are good educators or good communicators, but because they are good researchers. They often see teaching as something as secondary, and they don't have a clear understanding of the skills that they are expecting or would like to develop. So there are many, and then they will sit 400 students in a lecture hall and talk at them for an hour, okay, and wonder why only 10% or 15% of them can remember what they were talking about at the end, okay? I don't think even in schools you see that, because there's the realization that that doesn't work in that kind of way. So there are a lot of problems in university education. If I look on the positive side, I do think that in the area of physics education, biology education in universities, there is an increasing exploration of ways of improving what they do, and that is gradually creeping into the community in that kind of way. It's particularly in the American physics education community. There's a pretty large group of people, and the work that they have done on physics education and improving it is now quite well known. Okay, it hasn't spread in terms of the practices that they advocate that much, but it poses a challenge to what people are doing in universities.
Thank you.
Okay. Well, I mean, that's the address where I think if you want anything off the PowerPoint, that's where you have to email.